Hey everyone, and welcome to another Explainer. Today, we're taking a pretty fascinating journey into the anatomy of the machines we literally rely on every single day. I mean, we use them for work, we use them for entertainment, and they practically run our entire modern world. But how exactly are they put together? What makes them tick? Well, today, we're going completely under the hood to explore the absolute basics of information technology. We're going to focus specifically on computer architecture and its functional units. It's going to be a lot of fun.
Okay, so here's our roadmap for today. We'll start with what is a computer, look at the 5 functions of computers, explore the functional units, dive inside the brain, CPU, review input and output devices, and finally, wrap it up with putting it all together.
All right, let's jump right into section 1. What exactly is a computer?
So believe it or not, the word computer is actually derived from the ancient Latin word computare. This translates to calculate, to count, to sum up, or, and I honestly think this is quite beautiful, to think together. Highlighting this is so important because I think it instantly lowers the intimidation factor, right? A computer isn't some magical, unknowable mystery box. At its very roots, it's essentially just a machine designed to calculate and kind of think together with us to solve problems.
Fast forward to today, taking that Latin root with us, and we get our modern textbook definition. A computer is an electronic device that accepts input from the user, processes it according to the instructions given to it, and produces the required output. Look at how brilliantly simple that is. It's this super relatable 3-step loop. You give it something, it does the work you ask for, and then it gives you a result. This simple input, process, output loop, that forms the unshakable foundation of everything we're talking about today.
Moving right along to section 2. The 5 functions of computers.
Now, what's really wild about this slide is that these 5 steps are the universal framework for literally everything your machine handles. It really doesn't matter if you're just typing up some basic text, mixing audio, or rendering a massive high-res video. Your computer is relying on these exact 5 functions. Step 1, it accepts data. That's your input. Step 2, it stores that data. Step 3, it processes it. Step 4, it produces an output. And absolutely crucially, step 5, it controls all of these operations. This exact sequence is happening billions of times a second, right inside the device you are using to watch this right now. Crazy, right?
Which brings us to section 3, the functional units.
This introduces us to the core concept of computer architecture. I want you to think of architecture as the ultimate master blueprint. It's the exact specification of how a computer is designed. In really simple terms, it tells us how the hardware and the software interact to form a cohesive system. It details exactly how all these vastly different physical parts work together in perfect harmony to pull off those 5 functions we just learned about. And according to that master blueprint, every single computer system on Earth relies on 3 basic functional units. I actually like to use an anatomical metaphor here because it really makes it stick. Think of the input unit as our human senses, our eyes and ears, taking in raw information from the world around us. Then, the central processing unit, or CPU, well, that's our brain, making sense of all that raw info. And the output unit? That's our ability to communicate, like our voice or our hands, showing the world the final results of our brain's hard work.
All right, let's look closer at section 4. Inside the brain, CPU.
The CPU is, definitively, the brain of the computer. Its defining role is to process data according to the instructions that you provide. Just to reinforce our metaphor from a minute ago, the central processing unit is the absolute command center of the whole operation. Literally no processing happens and no tasks are completed without this specific unit orchestrating the effort.
So the CPU is just one big solid block, right? Actually, scratch that. It's not a monolithic block at all. It's actually made up of 3 specialized components, kind of like the different lobes of a human brain. First, we have the ALU, the arithmetic and logic unit. Think of this as the calculator lobe. It handles all the heavy math like addition, subtraction, division, and all those logical comparisons. Next up is the CU, or control unit. You can think of this one as the manager. It receives data, sends it out, coordinates the other components, and quite literally controls everything. Finally, we have the memory unit. This acts like a temporary filing cabinet. It just stores data and instructions, supplying them to the system whenever they're needed, right up until the processing is completely finished.
Next up, section 5. Input and output devices.
This whole dynamic is brilliantly illustrated when we look at everyday devices. Look at our input devices, things like keyboards, mice, scanners, barcode readers, even touchscreens. These act as the mechanical senses, helping us users enter raw data and commands, which get sent straight into the CPU. Now compare that to output devices, your monitor, printers, speakers, projectors. These are the communicative devices. They take the CPU's finished, polished work and display that processed information in a human-readable form. It's just a seamless, beautiful flow. Raw data goes in, processed information comes out.
And finally, Section 6, putting it all together. Looking at this sequence, you can really see how it all connects. Input flows to storage, which flows to processing, which ultimately yields output, and absolutely all of it is governed by control. This right here summarizes the complete working loop of a computer. The input unit accepts your data. The memory unit stores it. The ALU processes it. The output unit produces the readable result. And that control unit ensures every single step happens flawlessly. All those physical units perfectly executing the 5 major theoretical functions.
Now, you might see this pop up as a standard 5-mark exam question in traditional coursework, something like explain the functional units of a computer. But let's take it into the real world. Imagine you need to explain this to a colleague or a client. Even just 10 minutes ago, that might have seemed a little abstract or intimidating, right? But now, you are perfectly equipped to confidently describe the input unit, the CPU with its 3 distinct parts, the output unit, and precisely how they all talk to each other. You've got this down.
You know, you've done a fantastic job mastering the basics of this architecture today. But I do want to leave you with a bit of a provocative thought as we wrap up this explainer. Think back to the memory unit we discussed inside the CPU. Remember how I said it only keeps information temporarily until the processing is finished? Well, once the CPU is totally done processing and you want to save that data for next week or next year, where does all that data actually go? Where is its permanent home? That fascinating question is the exact jumping-off point for our next deep dive into primary and secondary memory, RAM and ROM. You absolutely won't want to miss it. Thank you so much for exploring this topic with me, and I will see you in the next one.